In this module, we're going to talk about loading data into MongoDB, and specifically what we're going to be focusing on is bulk inserts or batch inserts. Now, the logic behind doing a bulk insert, loading data in batches, is pretty simple and straightforward. Just do a quick illustration to show why single operations can be inefficient. So, in the single insert model, you send a write, so that's a write, you get a response, and you send another write, you get another response, and you continue on like that ad infinitum, right? So there's an overhead here. For every single piece of information you're sending in that particular write, you have to wait for the acknowledgement. Anyone who's familiar with TCP will know that this is how TCP was originally designed, and there's been extensions to TCP since, new ways of operating that sort of reduce this overhead. So imagine that instead of doing this singly, that you are able to send multiple writes. Let's just say there was 2 of them being sent, and get a single acknowledgement. Well, you've eliminated one waiting period here, one acknowledgement for a particular operation, and you can send 2 writes and get one acknowledgement when they both arrive, right? So that's basically batching up writes into the smallest batch size is 1, but the second smallest batch size of 2. So combine those 2 writes into a batch, and then this response for the whole batch. And the fact that this is a little bit more efficient, particularly if you multiply this out by hundreds or thousands of operations, is basically intuitively true, right? We know that not having to wait for multiple responses from MongoDB is going to be faster than having to wait for multiple responses from MongoDB to verify individual operations. This is quite a simplistic view, of course. We just have a client and a MongoDB. So what happens when you're in a sharded cluster? Well, when you're in a sharded cluster, we've got an extra layer. As we saw when we were going through the sort of mechanics of sharding, you've got the MongoS sitting in between. So let's draw that out. So now we have more moving parts, and I'm just drawing single MongoDBs here for the to represent the primaries in each shard. I've got 3 here. So a single write looks pretty much the same, right? A single write comes in, MongoS checks the shard key, and it decides which shard to put it on. In that case, we're going to send it here. The MongoDB will send your response, and the response goes back to the client. Yeah, there'll be some slight latency introduced here. There's going to be potentially a hop between the client and the MongoS, and a hop between the MongoS and the MongoDB, so there'll be a little bit extra network latency, but pretty minimal. So everything essentially looks the same for a single write. And when we go on to talk about batched writes, we have to kind of look at how batched writes really work. And essentially what you end up doing when you're sending a batch of operations is you basically send them as an array, right? So there's an array with, doc1. So you send an array of documents as part of the batch. So you've got document 1, document 2, all the way up to document n, for however many will actually fit in there. For a particular batch, you can potentially hit the maximum document size and other things here. But let's just say it's a sort of an infinite array for our current purposes. When this array hits the MongoS, each one of these documents is going to contain, your shard key and other info as part of it. So this one will have a shard key as well. And there's no guarantee that they'll all live on the same shard. If they did all live on the same shard, well, that would be fine if you can guarantee that in some manner. But you've got migrations going on here. There's splits happening. There might be migrations going on here. So to design this in principle, you can't just assume that when you batch up these documents here that they'll all be going to one spot on the back end, and that's where it becomes complicated. So what the MongoS has to do is it has to explode this array, so instead of having a nice batched array of operations to send to one particular point, you end up with the MongoS having to look at each individual document, determine the shard key, and then route it to the appropriate MongoDB. So let's just draw that out for a second so we can actually see what that might look like. This is, of course, a simplified model. I'm not including the get-last-error calls that I showed you in the previous timeline of how acknowledged writes actually work. So we've simplified this whole sequence a little bit just to make it readable. And similarly, making this a very simple sort of structure, not going into too much detail about where the shard key is and that kind of thing. So very simplified version of what's actually going on, but good enough for a sort of functional diagram of what's going to happen. So I've used orange as the color for the batch here. The client sends a batch to the MongoS. The MongoS does this explosion of all of the documents in it, examines each one, and then sends those batched operations to the correct MongoDB. And what I've represented here is 2 out of the 3 shards actually contained all of the documents in this batch. So all of the operations were sent to these first two MongoDs. They respond with the acknowledgement, if it was a W1 for example, that yes, this has actually worked, and then the MongoS responds back to the client saying yes, this batch update has actually worked. Now, so there will be an element of a delay here. The MongoS has to explode this, look at each one in sequence, essentially serializing them, and then send them to the right spot, get responses back, collate all those responses, and then give the response back to the client. You can think of that as basically a serialization delay. So that's how things are essentially currently working. So going back to our previous one, the client directly to a MongoD, so bypassing MongoS and just a single destination or a single replica set where you're writing to. Your bulk inserts, your batch inserts make an awful lot of sense. You're going to get efficiency gains. You're going to see higher throughput rates in terms of how much you can actually insert into the database or update in the database. You can have bulk updates as well, of course, various sort of things. So makes a lot of sense when you're going to a single replica set. When you see this sort of serialization delay here at the MongoS, it makes less sense. And in fact, you'll see if you move from a replica set with batch inserts to a sharded setup with batched inserts, you will actually see a drop off in performance. You get some gains from the parallelism here, being able to write to multiple MongoDs at a single time, but you then lose some performance in terms of that serialization delay in the MongoS. Good news is that this has been improved in 2.6 and beyond. The complete rework and refactoring of the update and writing code in MongoDB has had this effect. In fact, this is one of the stated goals of doing so. So the MongoS is making a much smarter job of serializing these operations, these documents over here on the right. And what it will actually be doing is attempting to group them together. So, if doc1 and doc2 are going to shard 1, and these are going to shard 2, then it will attempt to pipeline those and send them into a queue for shard 1, a queue for shard 2. So it's not quite the same level of delay in terms of the single operations being sent back and forth, serialized, sent back and forth to the MongoDs, and then finally being acknowledged back to the client. So there is some efficiency gains in 2.6, so the batch and bulk inserts in a sharded environment in 2.6 will have improved performance over their predecessors. This serialization delay will be quite evident to anyone with 2.4 or earlier.